Welcome to our webinar on Infrahub profiles. This is a capability that we're excited to kind of reintroduce. It's been around for a while, but we made a lot of improvements to it lately in recent releases. So we wanted to give a good overview of how it works and how companies can use it. And Wim, our product manager, is going to do an introduction of it. Oh, thank you. An introduction of profiles, what they're for, and then give us a quick demo at the end so we can see it in action. And quickly introduce myself. I'm the head of product at OpsMill, and then Wim is our product manager.
Okay. So before we get started and talking about profiles, we want to quickly introduce everyone to Infrahub. Hopefully some of you are already familiar with our product, but Infrahub is a unified data management platform for IT infrastructure automation and AI. To position ourselves a little bit, I'm going to reference the network automation framework reference architecture that has been introduced several months ago. Within that reference architecture, we are talking about an intent block, which is part of a network automation or IT infrastructure automation framework. In the intent layer, the intention is to store the intended state of the IT infrastructure and the business logic that is needed to provision that infrastructure. This is where Infrahub positions within that framework. The problem that we want to talk about today is that we have seen throughout the industry, throughout the IT industry, let's say, that a lot of incidents with IT infrastructure are caused by misconfigurations, leading to incidents that impact businesses in a very bad way. They could cause significant downtime, leading to loss of revenue, loss of reputation. Sometimes they could introduce accidental security exposure. In worst case, the consequences of security exposure you could end up in a very bad situation. So one of the solutions that network automation has been trying to solve is exactly the problem that we were describing before. So the premise was that network automation would help us reduce the amount of incidents that were caused by incorrect configuration on IT infrastructure by automating the configuration management aspects of that. But unfortunately, what we have seen is that configuration management within a network automation framework or an IT infrastructure automation framework is a hard problem, definitely when we talk about scale. It is a problem that leads to many frictions that we want to solve. So actually, the title of this slide is wrong. My apologies. So if you look at the existing landscape today, there's many ways that you could solve configuration management with automation. So first of all, we have the infrastructure as code approach. The problem there is when we want to enforce configuration standards with infrastructure as code, is that, and with infrastructure as code, we typically mean the GitHub style approach, where all of your data that is needed to set up your standards is stored in a Git repository, typically in plain text YAML files. The problem that we see is that you typically get a lot of loss of context when you define those standards within a Git repository. And the reason for that is that Git is not a database, meaning that there is no way to track which standards have been applied to which pieces of IT infrastructure as they evolve over time, where it's very hard to determine why a certain configuration setting on a piece of infrastructure was set. On top of that, in the infrastructure as code approach, you don't really have a good UI meaning that network operators or IT infrastructure operators need to understand what YAML files and GJA2 templates and JSON files would look like, which is a very hard problem for them. And it also means that the network operators themselves have a hard time operating within such a solution. Another approach that we see in the industry is going for purpose-built tools such as Netbox and Autobot that have also been trying to solve the configuration management at scale problem. The way they have tried to do that is by using device templates. But for example, one of the problems that we see with device templates is that they are tied to rigid schemas, meaning that if you want to set a configuration setting that is not really defined within that rigid schema, you can't really use device templates for that anymore. Also, device templates lose the connection as soon as you have created an object or a device, in this case, using such a device template, meaning that it's very hard to evolve your standards later on. And you would have to resort to manual scripting to apply new configuration standards. One of the solutions that Netbox and Autobot provides to set configuration standards for things that are not defined within their rigid schema is a configuration context, which is basically a JSON block where you can define your own data structure for specific configuration settings with their values. The problem that we mainly see with that is that, again, we reside to a data structure which is not easy to read by people that need to operate the IT infrastructure environment, and it's very hard for them to make changes to that. Another challenge that we see is that keeping track of exceptions becomes really hard when looking at such implementation. Last but not least, another solution that we have seen in the field is people building their own applications completely customized on top of some database. The downside to that is that, again, you will have to solve all of the problems that we have already previously discussed. But on top of that, this requires a lot of resources and skills within your organization. Development of such an application and solving all of those challenges by yourself is a very time-consuming task, and it is a very expensive solution. So that's why we have built a feature within Infrahub called Profiles. You can think of Infrahub Profiles as configuration blueprints. So it's a profile basically defines a set of values that you want to define, that you want to apply to a specific piece of infrastructure. And a profile can basically be reused to apply those values to a lot of pieces of infrastructure. So you can capture your standard settings within a profile and apply them to many pieces of infrastructure easily. One of the benefits of profiles is that you can use them for any infrastructure type. So they are not tied to specific rigid schemas. And the reason for that is that why they work like that is because profiles are based on the schema that the user has to define within Infrahub. So users have the capability to define their own data schema for any type of infrastructure within Infrahub, and Infrahub will generate profiles for any schema type that you define within its system. So it's not only applicable to, for example, a network device, but you could also use profiles on servers, on cloud infrastructure, you name it, any type of infrastructure that you want to model within Infrahub. Profiles in Infrahub support an inheritance model that is priority based. The reason we have built this inheritance model is because when we think about configuration standards, the way that we model a configuration standards, it's typically quite complex and influenced by a specific business decisions. This means that we need to have a high amount of flexibility in how we can define those standards. And that's why we support inheritance, which is basically the idea that you can define multiple profiles that apply to a specific type of infrastructure, but based on the priority of the profiles that are being applied, certain values will be inherited by that infrastructure, giving you ultimate flexibility on how those standards should be modeled. For example, when you have regional-based standards or standards based on a specific device type or on a specific device role, you can mix and match all of those together and enforce an inheritance model through priorities. With profiles, we also provide a capability to allow you to define exceptions. Let's be realistic, configuration standards are nice, but there is always this one-off situations where the standard will not apply or just simply cannot work. So we need a capability to be able to override exceptions. Now, the nice thing is that this combines very beautifully with other features within Infrahub, such as the proposed changes, which is basically a change management workflow where people have to review changes that are being proposed to the intended state of the network, meaning that whenever someone wants to create an exception, you can ask for justification and the reasoning why that exception is needed. It also means that you can keep track of those exceptions over time and go back to the proposed change and understand why that exception was allowed in the past in the first place, and see if that situation still applies and whether or not that exception should still be allowed on your network. Profiles also integrate nicely with the data lineage feature within Infrahub. This provides us a capability to understand where certain configuration settings are originating from. For example, when we think about a network device, we might define a specific NTP server on a device. And when you look at that device, you will see an NTP server. But through the data lineage feature, we will be able to tell you that that NTP server configured on the device is effectively coming from a profile, allowing you to understand why a device or a piece of IT infrastructure is configured in the way that you configure. Last but not least, profiles are database objects, meaning that they can track a relation between the profile itself and the objects or devices or IT infrastructure that you have applied them to, meaning that that connection is never being lost, and that allows you to evolve your configuration standard or your profile. For example, if we go back to the previous example of the NTP server, which is captured in a profile or a standard, in a few years from now, you might have to update that NTP server to a different NTP server. So you would want to automatically update all of the objects that that profile applies to. And this is what profiles allow you to do through that tracking of the objects that they've been applied to. So we can easily lifecycle the management of configuration standards throughout. One important distinction that we have to make is the difference between profiles and specifically object templates within Infrahub. So Infrahub is another feature which we call object templates. And when you look at object templates and profiles, it could become a little bit confusing. The main distinction between the two features is that object templates are mainly being used when you want to create infrastructure objects, whereas profiles are mainly used to enforce or apply values to specific properties of those infrastructure objects. Now, those values could also be defined in a template, but the difference is that with a template, you will not be able to change the value on the objects that you have created using that template later on. The reason for that is that object templates don't really track the objects that they have created in the past and do not have that rich connection that profiles do. Therefore, object templates are mainly used for data that is quite static and doesn't have to change significantly or frequently. Whereas profiles are more meant to be used in situations where properties or values of properties need to be able to change over time, and you want to be able to keep track of which values you have to change when you make a change in the profile. So that's a very important distinction that we want to make. Enough of the slides. I think we have tried to capture what we want to solve with profiles and how they do that. But I think it's better to show you. So on my screen, you will see an instance of Infrahub that is being pre-populated with a network already, the intended state of a network. So first of all, we have defined multiple locations, first of all, some countries and some sites within those countries. So for example, in Lyon, we have a set of devices, 2 routers, 4 switches. We have the same thing, for example, in Paris. We have the same thing in Mexico City, etc., etc., etc. Now, what we want to show you is how profiles can be used to enforce a specific configuration standard on those devices. So for that, we have modeled a device with an SNMP configuration. So what we can see here is all of the details of this particular device in Lyon. It has a status, a device type, platform, a role, etc., etc. But what we want to really be focusing on today is the domain name and the SNMP clients. So the domain name is something that we want to configure on the device, and the SNMP client that can call this device for operational information through SNMP is defined here as well. We have also defined a configuration artifact here for a specific device, which is the configuration, the intended configuration that we want to run on this device. We kept it really simple just to be able to focus on the important aspects for profiles, but we can see the host name being defined, the domain name of the device, an access list that is going to capture the SNMP client that can pull this device, and then we define a community that binds, that references that access list. Now, if we go back to the device, we can see that on the right side, there has been a profile applied. The profile specifically applied to this device is the device Europe profile. So if we click on that, we will see the definition of the profile. As you can see, all of the properties that were defined on the network device itself are returning within this profile. So what this allows us to do is basically define value for a specific property, an attribute, or a relationship, which will then be inherited by the devices that get that profile applied. So for example, we can see here that in the profile for devices in Europe, we have set the domain name to eu.optional.com, and we have defined a specific SNMP client. Now, if we go back to that Lyon router, we can see that it has inherited those values. Now, how am I so sure that these values are coming from the profile? Well, that's where the data lineage, or the metadata, as we call it, comes in Infrahub. If we click on the info icon here, we can see that the domain name, which is set for this device, is inherited from this particular profile. And very similarly, we can see that the SNMP server was inherited from the Euro profile as well. But if we, for example, look at the role, then we will see that it has a different source. In this case, we were using an object template to create this device, meaning that this attribute value came from the template and not from a profile. And for example, if you look at the name of the device, then we will see that the source is not provided, meaning that this is a user-provided value for this particular device. Now, if we navigate to the profiles, you will see that we have defined other profiles as well. For example, we have the one for the Americas, which defines a different SNMP client and a different domain name. And we have one specifically for which is not being used right now, but it defines yet another SNMP client. Do note that this profile is not setting the domain name for a good reason. The next thing that I want you to pay attention to is the profile priority, which is set to 100 here, and the one for Europe is 1,000. So the lowest priority has the wings basically. So when we apply multiple profiles, we will look at the priority of the profiles, and the lowest priority profile will win. But if the lowest priority profile does not provide a specific value for a property, then it could be inherited from a profile with a higher priority. And this is the exact case that we are going to show you next. So we want to start making a change to our infrastructure. The idea is that, as we have already covered, there is a new SNMP server introduced in our network. Specifically, we have added a new SNMP collector to the Lyon location because we want to offload specific SNMP traffic from this instance, which is overloaded. So within Infrahub, before you start making any changes to your IT infrastructure, the first thing we are going to do is create a branch, which is very similar to a branch that we are familiar with from Git. So we'll call it SNMP find. This branch is going to give us an isolated environment where we can prepare our changes without affecting the data in the main branch. The main branch typically being the actual intended state that should be the current state of our network. So within this branch, we are going to go to our devices again, and we're going to quickly change or apply the profile to all of our Lyon routers devices. So they already have the device Europe profile, but we're going to just be adding the Lyon profile as well. So let's add them here. While I'm doing that, Yvonne, did you see any questions up to now?
Is asking, can you assign the profiles at a site level?
So at this stage, you cannot do that yet. Profiles are still very tied to the objects that they apply to. However, this is one of the improvements that we have identified that we want to do in the future. So we are looking at a way that we can define or link profiles to the hierarchy that devices are part of, or also looking at how profiles could maybe be dynamically applied to devices based on specific attribute values, like, for example, the site or the type of the device or the role of the device. But yeah, that's something that is still in progress and that we are working on.
Good question, Eric.
Thank
Does
you.
anyone else have any questions? Not yet.
Okay. So we have made the changes. So we have applied the second profile now to our Lyon devices. So if we go and inspect one of them now, we can see that the SNMP server on this device in Lyon has been updated because we have applied that profile. remember that the Leon device profile had a lower priority, meaning that it wins for the properties that it defines. That is exactly what we can see here. The SNMP client is inherited from the device Leon profile. And the reason for that is, again, the priority. So both the Europe profile and the Leon profile define that client, define a client, but because of that lower priority on the Leon profile, it wins. As you hopefully remember, the domain name was not defined in the Leon profile. And therefore, the value that is applied to the device comes from the Europe profile, because the Leon profile does not define a value, but also the Europe profile is being applied and as a higher priority, we can still get this particular value. So now, if we open a proposed change in Infrahub, so this is the equivalent of a pull request in Git, or basically us saying that, hey, our change in our isolated environment is ready, and we are able to promote that into production or into our main branch. We open what we call proposed changes that allow you to do this type of change management. So let's give the proposed change a name. We could have a more descriptive message here, but for now, we're just going to quickly skip that. So when we open a proposed change, a lot of things are going to be happening in the background right now. So Infrahub is going to generate a diff of the data to represent what are the changes that happened within this branch. If we look at that diff, we will see here the devices that we applied the Leon profile to, which are exactly the Leon devices. If we expand on such a change, we will see that the SNMP clients have been updated. So we can see here that on the Leon router number 2, the initial SNMP client that was defined, inherited from Europe profile, was removed, and we have added a new SNMP server, the one that is now in Leon. And the reason for that is because of this profile change. We can see here that the device Leon profile was applied to that device, which has caused us to have this change, which is exactly the same change that we have on the other devices in Leon. Now, if we go and look at the artifacts tab, we will also see that the configuration has now been updated. Because of that profile change, the data changed, which implied that the configuration, the intended configuration for these devices needed to be updated. In Infrahub, we can do that using artifacts. Artifacts are generated as part of the CI pipeline process, which gets triggered when you open a proposed change. So we can see here that the IP address for all of the devices in the access list for SNMP has been updated to the IP address of the new server in Leon. And there's also a new community that has been defined that ties to the access list.
And before you move to the next tab, we have another question from Eric. He says, are there any safeguards that prevent overlapping conflicting priorities? Say I have 2 profiles with the same priority level and they both set the same attribute. Who wins or what happens?
So there is no guarantee there at all. When 2 profiles are being applied, it's undeterministic, I would say. So that should not ever be done at this stage. There is no way that we can define a good logic there. And unfortunately, right now, we don't really have a way to prevent that from happening. But it is also something that we will look into the future. But if you apply multiple profiles with the same priority, then you need to make sure that you do not set a value for the same properties right now. But it's definitely something that we want to improve in the future.
One more question before we move on. This is from Poonjang Patel. And I'm sorry if I mispronounced that. The question is, in your demo, you manually applied new profiles to some devices. How does it allow to tackle large number of devices, like more than 100 for such actions? So if we're changing,
Yeah, today you can do that using the GraphQL API or our Infrahub SDK. In one of the next versions of Infrahub, we are, again, it's aligned with the first question that we have, or it's very similar. So we are looking for a more dynamic way to apply profiles on specific pieces of infrastructure. For example, we want to be able to say that, I don't know, you want to apply a device profile for any device that gets created in the London site or any other thing in the hierarchy. So in the future, that will be more dynamic, but right now we don't really have a capability for that. I want to highlight though that we have talked about object templates before. So actually, if we go there, you can apply a profile through an object template. So you have a way to define that. Say you could create a specific device template for a device in a specific region, and then you can also apply the profile through that template. So now any object that we create using that template is automatically going to have that profile applied as well, which will allow you to automatically apply profiles to objects that you create. Hopefully that answers the question. Let me undo that change. Okay, so back to our proposed change. All of the tests have been completed. We can see that all of the checks that were run as part of the CI pipeline have completed. We are okay to merge this change. Once the merge has happened, we will do another quick type of a change. So the merge has happened. So if we go back to the main branch and look at our Lyon devices, we will see that the SNMP server is now the correct one. So now let's say we want to make an exception. So let's create a new branch, again for an infrastructure change. I don't know, quickly, I'm not really that creative today. So we'll create a branch test, and on this Lyon router, we want to be able to overwrite the domain name that is provided by the profile. So basically, we can now go here and say we have a different domain name here. Let's move that change in this branch, and the domain name has updated. Now, if we click on the metadata, we can see that the source is not the profile anymore, meaning that this attribute is now a user-defined value, and we can keep track of who updated that device through our metadata here. Refresh this one, it's not the correct change that we were seeing here. So in the activity log here, we can see that the admin has updated the domain name to overridden value of the profile. So now you could open again a proposed change where you could exactly explain why you have made this exception, keeping track record of that exception and why that exception was being made. And then you could, once it is being approved, merge that back into the main branch as well. Now, making a configuration standard changes becomes much more easier. So let's switch back to the main branch, and let's say that within Europe, we have a new SNMP server that we want to add to all of the devices in Europe. Let's go to that, to the profile. So the devices in Europe today use snmp.eu.opsmail.com. Let's say that we are going to migrate to a new SNMP server, and we want to apply that new standard to our devices in Europe. So rather than changing each device manually or creating a script to make that change, you can now just basically update the profile. So we have the SNMP client defined here. So what we can do is basically create a new SNMP client. Let's say SNMP EU2, and I'm doing SNMP2.eu.opsmail.com. We're going to give it an IP address. And now we have the second SNMP server defined. Now we will also have to add it to the community that we want to use. We're going to pick SNMP tool here. And now what we hope to see is that these changes have effectively populated to all of the devices in Europe. So if I now go to my router, for example, in London, I should see that the second SNMP server has been applied. So rather than going through this infrastructure change device by device, we could easily populate that new standard through the existing profile. Now, of course, because we are overriding the value for the SNMP clients in Lyon, on those devices, that change will not be reflected. Also, if you look at a device in New York, we can see that it is still using the value that comes from that particular profile. And with that, we have concluded.
One more question. Another question from Eric. He says, when defining profiles, are they tied to a particular kind in the schema, or do they just happen to share attribute names with objects that they are intended to be applied to?
So for every schema that you define, by default, we will generate what we call a profile schema. Maybe we quickly navigate to the schema here, and let's have a look at device. We can see here the schema of a network device, which is defined by the user and configured into Infrahub. Once you do that, you can see that each schema has by default a property set called generate profile to true, meaning that once you load this schema node into Infrahub, we will automatically generate a profile schema, which is going to have the exact same attributes and relationships that you have defined in the actual schema node that this profile was generated for. Also, this works quite intelligent, meaning that as soon as you upload a new schema or you update this schema to have a new attribute, for example, then automatically the profile schema will be updated as well. So profiles are tightly coupled with the schema that they apply to.
Eric is now asking, can you apply that to generics?
Profiles cannot be applied to generics today. I don't really see a use case for that, but happy to have a discussion on that topic. But just to recap, today we have shown you what Infrahub profiles are for. So one of the major use cases that we try to tackle with this feature is the ability to manage configuration standards for IT infrastructure in Infrahub, which traditionally has been a hard problem, which is a root cause of many IT infrastructure incidents. Network automation was one of the challenges that network automation wanted to solve was exactly that. But we have seen that the existing tooling that was out there in the industry didn't really quite fit the bill to be able to manage configuration standards at scale. And Infrahub profiles are a way to solve that particular problem. Thank you.
Oh, one more question from Eric. Did you show overrides?
Yes. So we have shown overrides through, maybe let's go back. So we had the devices in Lyon, where we initially only had the device Europe profile, which has a priority of 1000. And because of that, it had a specific SNMP server applied to it. Later on, we have added the device Lyon profile with a lower priority, which has a different SNMP server.
Eric responded, yes, thanks, not enough coffee yet. I think he did remember it.
Awesome. So that's how you can override. It's one of the ways. Another way is, of course, manually overriding profile values. But the exception case could also be seen as a way to override a profile value. Those are the two ways you can override profile values today.